Here we go. Alright. New school year, new class, new stuff going on. Same old setup for Kalimlin. Anyway, welcome to physics. This is gonna be like the recap video, notes, whatever, what we talked about on B-Day. We didn't do anything super relevant on A-Day. It was a lot of procedural stuff, but we talked about it, B-Day. Talked about four things. Four big, well, I guess technically it was two big ideas and then examples of those ideas, right? The big deal, the big thing, we're drawing in random spots now. Okay. The big deal, the big thing was this concept of scalars and vectors, right? So scalars and vectors are just two things, two ways that we classify the measurements that we take. In physics, just like chemistry, you're going to take a bunch of measurements. Eventually you'll do things with them, right? You'll analyze them. You'll compare them. You'll do some stuff with them. But first, just like last year in chemistry, we started with sig figs, we started with dimensional analysis, things like that. This year we had to start with, what are these measurements? So there are some measurements that are things that we call scalars. There are other measurements that are things that we call vectors, and in order to explain them, I'm going to use an example that hopefully you recognize, right? If you've driven in a car, or if you drive a car personally, then you should know that on the dashboard there is a little meter that measures your speed. We call it the speedometer. Now, your speed is something that you can measure, right? On like 481, most of 481 is speed limit of 65 miles an hour. 690 is anywhere from 65 miles an hour. I think it pops down to like 40, 45 miles an hour in parts of, in stretches where it's actually going through the city proper, but for the most part highways are anywhere from 45 to 65. Like country roads in the state of New York are 55. If you're on Randall Road just outside the Academy, people were saying it's 30 miles an hour. It's actually 20 miles an hour. School zone. But your speed, being a number, being something that is either big or small, it's something that has only a size. We call that a scalar, right? Because it's something that has only a size. So I like to use that because it has that letter association. Scalar, or speed, is a scalar because it has only size. Right? If I'm being super formal, then I would say that a scalar is something that, so it's a measurement with what we call magnitude. And magnitude is our fancy science word for size. So for example, speed. Like 50 miles per hour. Just like last year, all your numbers have to have units. So 50 miles per hour. Now, are we going to use miles per hour in class? Not so much. That's a US unit. It's an imperial unit. We'll use meters per second. But, we'll get there. We'll get to that. So scalars are anything that has just a magnitude, it's just a size. Vectors are also measurements. They're special, obviously. We gave them a special name. If you've seen Despicable Me, then you know why vectors are named vectors, even if you don't, realize it, right? If you've seen Despicable Me, then you should recognize that the villain of Despicable Me named himself Vector because he was a criminal who committed crimes that had both magnitude, which is a size, and a direction. So vectors are measurements that have both a magnitude, they have both a size, and they have a direction associated with them. Now speed is not a vector, because speed only tells you literally how fast are you going. There's another science term, there's a physics term that is slightly more precise than speed. It starts with a V, and it's why I like using it as my example for a vector. It's called velocity. So 50 miles an hour east. If I told y'all I was going 50 miles an hour, then I have told you my speed. But if I told y'all I was going 50 miles an hour east, that's a velocity. I told you not just where I'm going, not just which way I'm going, but I also told you what direction I'm going. If you want to identify something as a vector, then you need to see if it has both a size and a direction. If it has both, it's a vector. If it has only a size, if it's only how big is something, then it's a scalar. Directions are just directions. So somebody had asked, like, what about if it's just north? What if you say you're measuring something and it's north, and you're measuring a direction? That really won't happen that much, but anyway. There are two more examples that I'd like to use, right? If you were to measure how far away the mall is from CBA, if you were to get like a physical map and draw a line, how far away is it? It would be about 5 miles away. 5 miles, that's it. Now, 5 miles. Is that, what I just mentioned, is that a scalar or a vector? Now, 5 miles. Alright, that's how big the distance is. And there's no direction attached to it, so that must be a scalar. That, if I just say something is 5 miles away, that's a distance. And again, it's a scalar because there's no direction attached to it. If I just walked 5 miles away from CBA, I might be at the mall. There's a really good chance that I'm not going to be at the mall because there's a lot of ways to go. So if I want someone to actually get from CBA to the mall, then I need to tell them not only that the mall is 5 miles away, it's 5 miles away northwest. Now 5 miles northwest is no longer just a distance. It's distance and direction, which means that measurement is a vector. We have a special name for a distance and direction from a starting point to an ending point. The name that we give to that is displacement. So 5 miles northwest. So displacement, to be clear, is the distance and direction. Oh, that's not how you spell direction. From your starting spot to your ending spot. Alright? So, quick recap. Scalars are things that have only a size. You measure only their magnitude. You measure how big or how small they are. Things like speed and distance, those are scalars. Vectors are measurements that you can measure their size, and you also have to specify their direction. So velocity being 50 miles an hour east, displacement being 5 miles northwest, those are vectors. I like to use speed and velocity as your reference for scalars and vectors because of that letter association, the alliteration, right? This is our first big topic. We'll use this to classify other things, and it's important to remember about vectors because they'll be important. They'll be important over the year. Next time on C Day, we will mention something about acceleration and why I dislike the word deceleration. But in between now and then, so in between this video and the next one, make sure to do the scalars versus vectors identifying, or like listing scalars and vectors. Basically, I have a big list of scalars and vectors. I just want y'all to identify, is it a scalar or is it a vector? Is it just something with size? Is it just something with a magnitude? Or is it something with magnitude and direction? Right? Okay? I'll see y'all. Y'all will still meet. Y'all will see me on C-Day. And, yeah. Alright? Any questions? Email me. But in the meantime, be good. Stay safe. Stay sane. Take care.